is understand the algorithm itself. Implementing itself is not very complicated. Okay? With your minimal knowledge of the programming, so definitely you can implement by yourself. Even I provide a skeleton program, you don't have to stick on the Java program. If you prefer the C#.NET, ASP.NET, the PHP, any language you can use as long as I can compile it. Sometimes I'm not familiar with the specific language. You need to provide all the material that I can compile and run your program. Otherwise, I'm thinking about to set up the demo schedule for your project A and B with the GA. I will let you know about that sometime. If we do not have enough time, so I'm going to skip the demo for the second project. Definitely we will have the demo schedule for project A, your database. So, any question regarding to the indexing structure as well as the project B? For undergraduate student, it's extra work. So if you wanna get the extra point, so you can implement the project B, okay, B3 index. For graduate student, it's required. Okay? So mostly I consider the final and midterm exam is a 50% out of 100 in the final grade, and the others, the project plus the homework is the less than 10%, and the attendance is a 5%. The others will be project A and B. Okay. Then this week we are going to talk about another advanced topic in the database design. Actually, that should be part of the database design, but I intentionally put the after indexing structure to give more time to implement the project B. Okay? So it's a continuing of the database design. Sometimes after you followed all the steps that we have learned so far, the logical database design and physical database design that implemented the database system with the database programming technique, then it works very well first time. Then later, when after you launch the system, you may realize your system is getting slow. Also, you may find some redundant information that which may cause the problem of the data consistency. So in this class today, we are going to learn how to remove such a bad the database design and how we can make the current database design better and better. How can we do that? We are going to call such a process as the normalization. Is there anyone who heard about the database normalization? What is that? Normalize.
It's kind of
Enhancement? Yes, it's an enhancement. What does that mean, normalize? We use a lot, normalize.
how to decrease the number of attributes.
And just in general, what does that mean, the normalization? Remove the redundancy. If I ask to my wife what is the normalization, she doesn't know anything about attribute redundancy. What is the normalize?
To meet the standards?
Yeah, standard. We try to make a standard. That is the normalization. We try to make a standard database design in our database design. So in other words, normalization. Actually, if I translate the normalization into Korean, that is my first name. Really? So normal is actually the different meaning of the meaning of my first name is government, like the government officer, something like that. Probably my parents want me to be a government officer, which is the best job in the world, right? But another meaning of my first name is normal. So, for example, normal distribution. So, right? So, if I see the math book in Korea, at the end of the, I think the algebra 2 and the pre-calculus, my name appeared more than 100 times. So normal, every. So normalization. So in other words, normalization in database means so segmentation actually. we will learn why normalization means the segmentation or decomposition. Decomposition means we are going to separate, not distribute, segment. It's a divide. Okay? For example, do you think what is the main problem, main thing in database design? Let me change the question. Do you think what is the most hateful things by the database administrator? If you were a database administrator, what kind of data you hate most? It's not organized data, right? So you want to organize data. In other words, if data are redundant, that causes a lot of problem. What does that mean? Redundant data. Redundancy. For example, it's a repeat. My name is everywhere. For example, we are going to build a university database. So as an instructor, my name, the definitely payroll office needs my name. Also, administrator needs my name. My department needs my name. And student needs my name, right? So, if the payroll needs my name, instructor name, they build the instructor database. Okay? Also, administrative, they build their own database for instructor. Also, computer science department build their own database for instructor. Then what happened if I move to new address? Okay? So my address is changing. I need to inform payroll office, computer science department, administrative department, all department where there exists the instructor database. That's called redundant. Redundance causes a bunch of problems. First, waste of space, right? So my name is everywhere, so that keeps the certain space. Also, in case I update the data, I need to update all of the data. If we miss to update one of that, that may cause the problem. Okay? So who will see such a problem? That is called update anomaly. Okay? That causes the update anomaly. Also, what else? So we lose data consistency. So if we have redundant information, we cannot keep the purity of the data. Okay? So that is the reason database administrator, database developer, database guys really want to keep the redundant free database data. Then how can we make redundant free database? What is the ideal case? How can you avoid redundancy? There's a best way, an easy way in terms of the database design. You can make single attribute table, right? The first name table, last name table, and middle name initial table, whatever that. There might be no redundant, right? Because it has only one attribute. What? But anyway, so there's no redundant. So single unit, single attribute table. That's called a unit table. Okay?
Can you give the performance and behavior?
Yes, performance will be issue. We will see why it causes the problem. Then how can we address that problem? Anyway, so we don't want such a thing. So is there any guideline? Not also the opposite of this. If we consider performance or exactly opposite of this one is we can build one big table for university that keep all the attributes, student, instructor, and staff, everything. Okay? But this one may cause the problem. So is there any way to make the best one. So that is called the normalization. We are going to find the process to normalize, to make the best design, okay? That reduce the redundancy and that can increase the performance. Okay. So there are two ways to normalize, to make our database design better. The first one is informal way. Informal way, informal guideline. The second is formal way, formal definition. So, what does that mean? Informal way. Informal means, formal means mathematics, okay? And informal means non-mathematics in English, okay? So, first, formal definition is a little bit complicated to understand. Dr. E.F. Code, when he proposed a relational database, the model, he used the mathematical concept, but we are not the mathematicians. So first we are going to see what is the informal guideline to make the better database design. Then we will see formal definition. That process is called normalization. At that time, we will use functional dependence. Okay, that is the chapter that we are going to discuss today. So, first guideline to make our database design better. Before we start, why don't we go back to before we start this class? So before the spring semester began. At that time, some of you guys already knows about the database. Some of you guys already use the relational database management system, such as SQL Server in your programming class. Sometimes on the project, the project, you already use. At that time, did you take any database design course? No. Even though I do not took any database design course, I can use. Even I can design my database. How can you do that? How can you do that? You're a genius? Actually, even though you do not know anything about the database design process, including ER modeling, relational modeling, normalization, whatever, even though you do not know such a thing, if you are a normal person, really normal, general person, you can do the certain level of database design intuitively. Okay? That will be in terms of a formal definition. We will see third normalization form. Okay? Later we will see at the end of today's class, we will see what is the third normalization form. It's almost 90% of database. This is third normalization form is enough, which means even though we do not take this course, if we design the database intuitively, so almost a certain level of the database design. Okay? For example, if I ask you, why don't you build a university database? Everybody can imagine. We need student table. We need instructor table. We need administrator table. We need course table. Even though you do not know many-to-many relationship, you can create the registration table. And there is a student table. There is the instructor table. You can make it. At the time, did you consider the many-to-many relationship? No. Without the knowledge of such a cardinality, whatever, everybody can do certain level of database design. Okay, that's true. So that is this guideline. Okay, the first guideline is simple. Each relation, each table represents only one meaning. What does it mean? The first guideline. What does it mean? You think it's very complicated? It's an obvious thing, right? Nobody wants to put the database node, operating system, course node, and the programming in together. Nobody wants. you want to use this notebook for database, and you want to use the set another book for operating system, something like that. You already organized, right? Same thing. When you create the table, when you create the database design, one entity, one table, one relation represent only one meaning. For example, in this table, I write for student plus instructor. Yes, we can do that, but that will be complicated, right? So that is the first guideline. First guideline means one table represent one meaning. Okay? For example, this one, as you can see, employee. This is only for employee. This is for only department. This is for department location. This is for project. This is workshop. Even though we do not consider many-to-many relationship or the what is that? The multi-valued attribute, but you can do is the database design by following simple guidelines. Okay. Next. Second guideline is no insert, no delete, no update anomaly. So to understand the second guideline, we should know what is the insert, update, delete anomaly. So I design this table, EMP underbar DPT. Even that doesn't follow first guideline, right? So this is the employee ID plus DPT ID. Even though this one does not follow the first guideline, okay, the first one, it's just first one, so we will ignore. Then create a table, employee underbar department. First, I'd like to hire the new employee. Okay, new employee for the new department. So we'd like to make the new department and hire, then assign that employee the new department. Can you insert that employee into this table? No. Why? Because we do not have the department information. So to create the new employee, you should have the department information. That is called insert anomaly. Also vice versa. So anyway, so we got the employee ID and department number ID is 1, and this is the employee information, this is the department information. I'd like to fire this employee. What happens? If this employee is the only employee in this department 1, this department will be automatically removed. That which I don't want. But because of bad design, poor design, this table will be deleted. This data will be deleted unexpected. So this is called delete anomaly. Also, I have the, so anyway, we ignore such a problem, so we create the bunch of tuples. So department ID 1 has 1, 2, 3, 4. And department information location of this one is LA. LA, LA, LA. This department moved to the Dallas. How many times do I need to update? 1, 2, 3, all tuples that have the same department ID. Actually, we better update just one time if we keep this information separately. This is called update anomaly. So your bad, poor database design may cause insert anomaly, delete anomaly, update anomaly. So second guideline is we don't want such an insert, update, delete anomaly during the database design. Okay? You see, very complicated. You already know about such a anomaly guideline. Okay? Then, next one is null. What is null? Null means nobody. Yes, not exist. There is no data, no value for specific power attribute. Okay? At that time, even though there is no data, how can you maintain null data in your database? Just leave blank. You need to make the structure, right? To indicate. For example, in C program, how can you implement the array? Did I mention about the C programming that I done? Most of students who are learning the C program, either when they learn pointer. Okay? Using pointer, you can implement array. For example, string. Okay? So string is nothing but the array pointer. So you have leave. That's it? No, you should have null pointer, right? That indicate end of the string. Okay? So anyway, null to represent null, even though meaning of null is nothing, you need to specify. You need to use the data byte, 1 byte or 2 byte, 3 byte, certain number of bytes in your physical database structure. Okay? If you have a bunch of null in your database design, that means waste of space. Also, it's a performance degrade. So in your database design, null-free database, no, that's not possible actually. It's an ideal case. So as less null as possible. So that is the third guideline. So first guideline, simple. One table, one mean. Second guideline, no anomaly. Insert, delete, update on. No insert, no update, no delete anomaly. The third guideline, as less null as possible. If you keep such a basic guideline, your database design may be reasonable. Okay? And next one is based on the join. You know what is the join? Join operation required to combine two tables. However, in case your database design is not good enough, when you join two tables, that may cause unexpected data. Let's see the example. So we have, let's say, two tables. Even these two tables does not follow the first guideline and second guideline. Okay? So but we ignore that. So we have two, because just like your final exam, so after final exam, all students argue my answer is correct. So let's accept you are up here. So we have the two tables. Employee underbar location, employee underbar project. In case we join two tables, okay? So let's this time two tables, okay? In this case, why don't we use the natural rule? What is the natural rule? Join with same name of column, okay? Automatically, which means join P location with P location, value. So we join these two tuples, and then there. Where is it? Okay, that's it. And superlap, join, and superlap, and so on. Then we will get this kind of result. However, how many? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 times this number of tuples will be created after join. However, what about this one? 1, 2, 3, 4, 5, 6, 7, 8, 9. It's not actually Joyce English. It's supposed to be Smith. John Smith is the 1 to 9 social security number. So this one is not expected. Actually bad example. Why we got such a thing? Because your database design is not correct, not good enough. So your bad design may cause unexpected data that is called spurious tuples. So you avoid such a spurious tuple. How can we avoid? Okay. So follow first, second, third guideline correctly. Then the first guideline will be resolved. That is the first guideline. Okay. So even these guidelines are good enough to make the good database design. Okay? But not always. This is nothing but just informal guideline. It doesn't cover each and every case. So Dr. E.F. Goddard thought about, is there any way, formal way to define, okay, such a process, guideline process, which is called normalization. By the way, when you see the first through the first guideline, what is the most important? The first guideline is the one meaning, one table. Second guideline, no spurious. Insert, more insert, then update. No anomaly. How can you make the no anomaly? What is the most important point? Most of the case, if something problem, what caused that problem? Redundant. First guideline, if you keep the two meaning, which means redundant information. Second guideline, redundant information. Third guideline, since you keep the more meaning, more semantic, more information into one table, that may cause the many nulls. So it's a redundant information. First guideline is the same. So mostly the redundant information causes such a problem. In other words, can we define, okay? Informally I said it's meaning, right? Well, informally I said the semantic meaning or redundant. So we are going to formally define such a meaning or goodness of the database design. How can we define? Can you remember? What is this? It's a function, right? X is the input and Y is the output. So if we have input, Y will be automatically determined, for example, times 2. In case of 2, it will be 4. 100, 200. X determine Y in case of function. So who will use such a concept in database design? For example, in employee table. Social security, if you know the social security number, okay, you may know name, ID, address, gender, everything, right? So in other words, social security number determine this one. Social security number That's the input, output, other information. In other words, this information is determined by social security number. At that time, this is called functional dependence. Using function, we are going to define the dependence of what? Attribute. So, functional dependency means it's not just x and y. X means actually what? It's a set in the function. Y means set in function. Similarly, x is a set of attributes. Y is set of attribute. So, set of attribute determine set of attribute. That is called functional dependence. So, first thing we are going to identify functional dependency. Then we can say functional dependency is the same as what? Meaning or semantics or table. Good. Question. How many functional dependencies do you want in one table? Just one. We want one functional dependency. Actually, it's not functional dependency, it's a minimal functional dependency. We will see why. Before that, functional dependency means it's a constraint between what? A set of attributes. Okay? So one set of attribute x determines another set of attributes y. So let's see the example. In this case, we have P and P on the one table. Can you find any functional dependency? Yes. Social security number determine e-name. This is one functional dependency. And any other? Social security number determine e-date. And social security number determine address. Why don't you consider only this part first? Is that the all functional dependencies that you can find? Actually, more than that. What about SSN plus e-name? Using social security number and e-name, you can identify e-date. Social security number plus e-date determine address. How many? There are many functional dependencies you can find. But what we are interested in, the functional dependencies, we need social security number determine e-name, e-date, address, right? This is called minimal functional dependency. So we need identify not just the functional dependency, but minimal functional dependency. Intuitively, you can identify such a minimal functional dependency. In this case, social security number determine e-name, e-date, address. What about this one? We can also identify D number determine D name. D number determine D manager underbar social security number. Also D number plus D name determine D manager social security number. D number plus address also determine D name. There are many functional dependencies, but we can identify D number determine D name and D manager SSN. This is called minimal functional dependency. So, how many minimal functional dependency in this table? 2. Okay? So that is what we are interested in. Not just general functional dependencies, but minimal functional dependency. That determines what? Meaning of the first guideline is one meaning, one table in one table. How can we define the meaning? Using minimal functional dependency. To represent such a minimal functional dependency, we can use arrow, like this one. What about this employee underbar project here? How many functional dependencies can you identify? Many. It's limited, but there are many functional dependencies in this example, but we are interested in minimal functional dependency. That is, first one is the social security number and P number determine hours. That's one minimal functional dependency. Another minimal functional dependency is social security number determine e-name. Third one is P number determine P name and P location. How many minimal functional dependencies? Two. One is for, this one is for employee. This one is for project. And this one is for work scope. Right? How many hours for each employee on specific project? So, according to the informal guideline that we discussed, how many different meanings in this table? 3 different meanings. Is it good design or bad design? It's very bad design. That may cause a lot of the anomalies problem and huge number of null data. So we need to address them problem. Okay? So this is the functional dependency. However, from now on, when I'm saying the functional dependency, that means it's a minimal functional dependency. Okay? Nobody wants to say the minimal. So database guy, like the computer science guy, the computer engineer, we want abbreviation or the shorten or simplify. So when I'm saying the functional dependency, that means minimal functional dependencies. Okay? So this is the other example. Social security number determine e-name, P number determine, and so on. However, I did not explain functional dependency and minimal functional dependency formally. Still, I explained it informally. There is a way to find the minimal functional dependency formally. That is described here. In first rule, there is a rule for functional dependency, and there is an equivalence and the minimal set, and finally there is a algorithm. There is an algorithm to find the minimal dependency. I tried to explain in the class by using 2 weeks, and only few students understand. So I realized that actually this one does not need, but if you are interested in the research on database, sometimes I find, who knows, you find the new ways of the design, new ways of database design. At that time, you need to explain how it works, how to model. At that time, you can use this kind of approach as a reference. Okay? So this is the mathematical proof of the how to find minimal dependency. Idea, I try to give the idea. Idea is left-hand side, X side. We don't need additional information, like the social security number and e-name. E-name is additional information. We try to get rid of such the additional attribute. How can we do that? Take out one of these. See whether right-hand side is changed or even though I take out this one, the output is the same. We don't need this, right? This is the idea. Then right-hand side, first make a single attribute. Then later, when you have the social security number determine something, social security number determine something, then you can combine right-hand side. So this social security number determine this one and this one. Okay? eventually this left-hand side will be used for primary. Okay? Because that determines this one. Actually not primary key, it's a key, including primary key and candidate key. Okay? Can you remember the candidate key? One table may have many candidate keys, like the employee. Employee table has social security number as a key, and also employee ID as a key. You can select one of them as a primary key, the other will be secondary key. So this part is the key part, candidate key part. Okay? So this attribute is called prime attribute. This one, right hand side, non-prime attribute. This is very important during the normalization next. Okay. So this is the minimal functional dependency. This is the example. I used this example exactly same as the slide for final exam. Most of the students incorrect answering. So I'm going to skip, but if you are interested in the formal definition of the functional dependency, you can check it, check out the textbook as well as this one. Okay. Then we define the functional dependency. Also, minimal functional dependency. Left-hand side is the prime attribute. Right-hand side is a non-prime attribute. Then, how can we make this database design better? Okay? That does not make any duplication, redundant information, insert, update, delete anomaly, then redundant-free database. So, using what? Functional dependency. Actually, minimal functional dependency. How can we make? This one is better database design. That process is called normalization. We are going to normalize this one. As I said, normalize means something is a segmentation. So, the initial database design, without understanding the database design, database concept, just collect all the information. Okay? You don't consider any guideline, any database design technique, just collect all the information. That is called zero normalization form or unnormalization form. Just collect all the information. It's just a big table, one big table. Okay? So, that may cause a bunch of problems, right? It has a lot of information in one table, and also insert, delete, update anomaly, many nulls and superiors, the tuple when we join this one, this table with the other. So this is called unnormalization form. This is unnormalized. Normalization process is kind of reduce redundant information. We are going to remove redundancy. At one time, no, it's not easy to remove the redundancy. At one time, we are going to reduce step by step. So, first step, first normalization. Second, if we apply the second step, that is called second normalization form. Each one has more redundancy. First normal form, second normal form. The first normal form is general, which means more redundant information. What do you want? First normal form, second normal form. Second normal form. Then, even that's not enough, so we apply third normalization form. Then, third normalization form that I mentioned here. If you are a normal person, everybody can do up to third normalization form automatically, intuitively. Okay? Actually, 90% of the real database design need only just the third normalization form, which means without taking this course, you can do database design for 90% of real database. That's the reason you already did the database design in your programming class, right? So this is third normal form. The next one is, unfortunately not first, it's a BCNF. Both code, Dr. EF code, and his friend, the Bosch and code, there is by following their name, BCNF. Both code normalization form. Then fourth normal form, fifth normal form, and so on. We are going to cover up to BCNF in this class. That covered 99% of real database design. However, the rest of the 1% make the issues. So in case you need, consider first normal form, fifth normal form, and so on. You can take a look at the textbook and easily catch up. You don't have to. But at least you need to understand up to BCNF. So what we see, how can we make that? Basically, this process is called normalization. In other words, it's called somewhere here, segmentation, decomposition, which means we are going to separate by to reduce redundant information. Separate, segment, decompose. How? Based on what? Functional dependency. Using functional dependency, we will segment. That's everything. So, normal form. Probably you heard about the normalization. So if you are eager to get a job in the United States, you already visited the monster.com, careerbuilder.com, then if you type the database or the database developer as a keyword, most of job description require what? Experience on normalization, experience on logical database design, experience on physical database. Physical database design is a little bit the senior level, but here it adds. So that is normalization. So normalization is this thing that I explained. The mostly, usually, it's up to the BCNF. The higher level of the normalization form is not very complicated. When you need to consider the higher normalization form, so you can take a look at this textbook. Okay. So in other words, normalization process is called decomposition. How can we decompose? By using the functional dependency. However, either case is this one. Right? There's no redundant. We can normalize extremely. This is normalized one. That satisfies definitely every condition in this case. However, you don't want such a database. Why? Why? Why not? What is the main problem? There's many joins, right? To access the data, you need only the last name only, first name only. Probably you need to access last name, first name, middle name, initial, and more information. At the time, you need to join. Unfortunately, join operation is the most expensive operation that we'll discuss the next class. Okay? Why join operation is very, very expensive. So that join operation costs the downgrade of your performance. We need to go back to unnormalized. Actually, not unnormalized, certain level of normalization. Even though that violate some redundant information, but we accept such as the violation, redundant information. Instead, we are going to pursue the performance. That is called denormalization. Sometimes we need to go back. Normalization is that's not guaranteed the best performance. It guarantees less redundant information. That doesn't mean it's the best performance. So if you are serious for such a performance, you need to denormalize. Go back to the process. But we are not going to consider the denormalization in this, but practically it happens. How do you decide which one should be denormalized? How? You remember the first handout? There are two processes in database design. One is data analysis. Another one is application analysis. Okay? Then you learned this part in software engineering and programming class, but we didn't pay attention to this part. However, when you design the database, you need to consider the application analysis at the same time. For example, employee and department